All right, guys, I think we're down to our last example. This one is similar to the one we did in 6.4, where I talked about finding the slopes and the distance formula and the shortcut using it when we were using graphs, which is the nice thing about this one. So it's always recommended, if you can, to use graphs. So we want to determine whether this parallelogram ABCD is a rhombus, rectangle, or a square. Now, by just looking at it and from the situations that we've been in, it appears that from the graph that the parallelogram is a possibility a rhombus, a rectangle, and a square. Now, the only way we can tell if it's specifically one or the other or all three is by its diagonals. Okay, if the diagonals are perpendicular, then ABC D is either a rhombus or it is a square. The diagonals of a rectangle are congruent. So if the diagonals are congruent and perpendicular, then ABCD is a square. So like before, we can use the distance formula here, but let's go ahead and show the short version of this. So we're going to talk about specifically the diagonals here. So we want to find out this diagonal right here, and we want to find out what its distance is and its slope. Okay, so that is basically using the same exact thing for both of them. So let's do this here. So we're going to go straight down from here. Gotta love my straight lines. And then over to here, we count the units. So units are 1, 2, 3, 4, 5. Okay, so we have a 5 here on this one. Okay, and then we count over 1, 2, 3. Okay, now we do the same thing for the other diagonal. And we can sit there and say the slope on this one, first of all, is 5 over 3. And if we want to do the distance formula of it, it would be 5 squared plus 3 squared. And then we find the square root of it. So this would be 25 plus 9, which equals 34. And then we would take the square root of that if necessary. Okay, so let's change the color for the other diagonal and do the exact same thing. We can do this one, let's say, lighter purple. So we're going to go this direction now. We're going to go up this way. Okay, and then we're going to do the same thing here. Let's use a different color. Let's use orange to do our counting on this one. So we're going to go down. Well, it's ended up staying purple, and then over. Okay, so this is 1, 2, 3. And then we went over 1, 2, 3, 4, 5. So guess what? They are a what? A match. So we have again, well, not a match necessarily. Let's look at this again here because we went down 3. Okay, so that means we're going to go, it's going to be 5 over, 3 over 5. Okay, because this is our rise. And since we went down, that's going to be negative. So now remember, in order for them to be perpendicular, this goes back from last semester, this is 5/3, and this is negative 3/5. So what that means is if they're opposite reciprocals of each other, that means that they are perpendicular to each other. So first one goes. And then we have the same thing here. Even though it's a negative 3, we can still go negative 3 squared plus 5 squared. And we know that, anytime we square something to negative, it's going to turn to positive. And then we get 5 squared, which gives us 25. Again, 9 plus 25 equals 34. And we take the square root of it. And there's a match. So because the slopes are opposite reciprocal of each other and the distances are the same, we go ahead and solve this, and we find out that the slopes Okay, so ABCD rhombus or parallelogram or quadrilateral ABCD is a rhombus and a rectangle and a square. You can verify ABC is a square by using the distance formula to show that all four sides are congruent, and by using the slope formula to show consecutive sides that are perpendicular. But there's no need for us to do that in this case. Okay, so there's our example for that one. You're going to pretty much do the same thing in year one. You're going to do by yourself. I believe it's a multiple choice scenario, but it would be best if you drew to figure it out. You can either do it on your screen or you can do it on a piece of paper at home. All right, have any questions, just message me on Teams and we can talk about it. All right, have a good one.